the save call operator. A nullable variable also cannot be used to call a function or to access a property in the usual way. Earlier in this lecture, we used two uppercase function was called a string object, given the possibility that this code calls a function to be called on a null reference. So this code I will write here is disallowed by the compiler here, and this will give an exception, an error here. Val, for example, val my name, and this net assigned to string here, use string and make this string nullable and assign to null here, and val uppercase my name, and let's do this and assign it to username and uppercase. Oops, no, username my name dot uppercase, as you can see here. The exact error you will see here on save or null asserted calls are allowed on nullable receiver of type string. So in this instance, the compiler is essentially refusing to allow the function call to be made because no attempt has been made to verify that variable is non-null. One way around this is to add some code to verify that something other than null value has been assigned to the variable prior to making the function call here. Let's make an add condition here as we did earlier. So if my name is not equals to null, you will see conditional and expressions later lectures, next lectures. And while uppercase my name is equals my name dot uppercase. As you can see here, our error is gone here. A much more efficient way to achieve this same verification, however, is to call a function using the save call operator. So delete this now, and let's do another condition. Uppercase my name, assign it to my name dot or a question mark and dot to uppercase. In this example, if the username variable is null, the uppercase function will not be called and execution will proceed at the next line of code. If, on the other hand, a non-null value is assigned to uppercase, function will be called and the result assigned to uppercase my name variable. Let's discuss about not null assertion here. A not null assertion removes all of the compiler restriction from a nullable type, allowing it to be used in the same ways as non-null type, even if it has been assigned a null value. The assertion is implemented using double exclamation marks after the variable. For example, while username and add string and question mark equals null, and I want val length of our username and equals username dot double exclamation mark here and dot length. This code will now compile but will crash with let's compile it. It will crash, of course. I know that it will crash. As you can see here, our code is crashed because of this 19th line code. So clearly this causes the very issue that nullable types are designed to avoid. Use of the not null assertion is generally discouraged and should only be used in situations where you are certain that the value will not be null. Nullable types and let functions. Earlier in this lecture, we have looked at how the save call operator can be used when making a call function belonging to a nullable type. Let me delete this. This technique makes it easier to check if a value is null, and if a value is null and so let me check if our video lecture is recording. Yes. So this technique makes it easier to check if a value is null without having to write an if statement every time the variable is accessed, as we did earlier. Let me show you. We did earlier that. Okay, as you can see here, we will this with save with let function, this will more or less code. A similar problem occurs when passing a nullable type as an argument to a function which is expecting a non-null parameter here. And as an example, consider the times function of the integer data type. When called on an integer object and passed another integer value as an argument, the function multiplies the two values and returns the result. When this code, for example, I want to show you here. Okay, let's delete this and let's create a val first number equals to 10 and val second number equals to 20 and val result equals first number dot times second number. So let's print our result. Text view dot set text result dot to string. I want to show you here. Okay. As you can see here, our final result is 200. Let me close this. So now, for example, let's create an second number non-null type. A problem, however, occurs if the second number variable is integer and non-null type. Here is an example. Second number int will be integer but with no null type here, and as you can see, we give an error basically because of the type mismatch. Now the compilation will fail, of course, with the following error message. Let's compile. As you can see here, we have a type mismatch error, which is our program is not compiled here. So let's fix this with another solution. A possible solution to this problem is to simply write an if statement to verify that the value assigned variable is not null before making this call function as we did earlier. Let's did another again, which I will show you the best result with how to use this result here. Okay, if our second number not equals to null and print this. A more convenient approach to addressing this issue, however, involves use of the let function here. Let's delete this, and so when called on a nullable type object, the let function converts the nullable type to a non-null variable and named it, which may be referenced within a lambda statement. For example, second number and second number here, and a question mark dot let, and val oops no, not here. For example, second number dot question mark dot let, and we will write our code val result here, and equals first number dot times dot it here. In it is the second number here with let keyword. Note use of the safe call operator when calling the let function on second variable. In this example, this ensures that the function is only called when the variable assigned to non-null value. We have another way to initialize null values, which is late init function. Late initialization or late init. So as we previously outlined, non-null types need to be initialized when they are declared. This can be inconvenient if the value to be assigned to the null variable will not be known until later in the code execution. One way around this is to declare the variable using the late init modifier. This modifier designates that a value will be initialized with the value later. This has the advantage that a non-null type can be declared before it is initialized, and with this advantage that programmer is responsible for ensuring that the initialization has been performed before attempting to access the variable. For example, consider this variable declaration var my name string. Clearly, this is invalid since the variables is a non-null type but has not been assigned a value. Suppose, however, that the value to be assigned to variable will not be known until later in the program execution. In this case, the late init modifier can be used like this. Late init here. So, with the variable declared in this way, the value can be assigned later. For example, my name Android Studio here. Of course, if the variable is accessed before it's initialized, the code will fail with an exception. For example, let's print our my name. Print here my name. Oops, not my name. My name. As you can see here, we have not an exception here. Late init var my name's string. If we put this here, this will give us an error here. So we have an else operator as well here in Kotlin. The Kotlin else operator can be used in conjunction with nullable types to define a default value that is to be returned in the event that a value or expression result is null. The else operator is written like this. Oops. Else operator is written like a question mark and 2 colon. It's used to this separate as an else operator is used to separate two expressions. If the expression on the left does not resolve to a null value, that value is returned. Otherwise, the result of the rightmost expression is returned. This can be through a quick alternative writing of an if-else statement to check for a null value. For example, let's create an example of if let's create my string, my var my string here, and assign make it string, and equals for example hello world, and here if our in traditional way with conditions without else operator, we as you learned, we've written expressions conditions like that, which we haven't been discussed conditions. You will learn condition in depth in later lectures, next lectures. And if my string not equals to null, then return my string here, else here string return string is null is null here. So the same result can be achieved as with else operator here. Let me do this. Okay, let's do this condition with else operator. Return my string and my string question mark and semicolon here, and string is null, as you can see here.